Today we're going to check our homework from pages 1 through 3, and then we're going to go on and learn about parallel lines and what that does to the angles that we discovered yesterday, and then do a little practice. So when we go on to, let's see if I can do it. Let me grab my pointer up there. And when we look at our homework from last night, let's see if I can pull this over. Let's take a break here. Let's stop and let's look and see if we have any questions. Identifying angles down here by the transversal. Notice that I named the transversal as well. And the next page, this must be page 5. Coming up with our proofs here. Look at those carefully. And our last page, page 6. These will also be in Google Classroom after the class, so you can look them over again. Okay, so take a minute and look at these 3 pages and see if you have any questions before we move on. Okay, so today we're going to look at what happens when we have a transversal that happens to be cutting through 2 parallel lines. So when I see a transversal and I can see that it's cutting through 2 parallel lines, and that's what those red arrowheads are telling me. This line is parallel to this line, and here's my transversal, and you can identify it with a T if you'd like. We still get the 8 angles that are created, but now since we know that we have 2 parallel lines, not only are our vertical angles congruent, like 1 is congruent to 7, 3 is congruent to 5, just because they're vertical, I also know that I've got other angles that are congruent, and those are my corresponding angles. So angle 1 is congruent to angle 3. They're in corresponding locations. Angle 2 is going to be congruent to angle 4. I know that angle 8 is congruent to angle 6, and angle 7 is congruent to angle 5. Again, those are relationships we learned about yesterday, corresponding angles. And when a transversal cuts between 2 parallel lines, the corresponding angles will be congruent. And that's what this postulate says, the corresponding angle postulate. It does require the transversal to cut between parallel lines. Okay, let's look at practicing this a little bit. Let's see if we can figure things out. First thing I want to ask myself, are the lines parallel that I'm cutting between? Okay, I can see they're parallel because they've got those red arrowheads, so they are parallel. Here's my transversal. In this case, my transversal is labeled Z, but don't let that fool you. It's the transversal because it cuts between 2 lines. Okay, if the measure of angle 11 is 51, so I'm going to put a little 51 right in my diagram, and you can do the same so I don't forget. Can we find the measure of angle 15? So if 11 is 51, what is the relationship from 11 to angle 15? That's right, they are corresponding angles. So angle 51 must also equal, angle 15 must also equal 51 degrees because these 2 angles will be congruent. They are in corresponding locations. Now let's look at angle 16. If angle 15 is 51, angle 16, which is vertical to it, these are vertical angles, would also equal 51 degrees because vertical angles are congruent anywhere, anytime. So this is vertical to 15. It is also alternate exterior, so we're going to see what happens there. Okay, let's check the next group of problems here, the next group of theorems. Now, there's something called the alternate interior theorem, so put a star by that. Okay, because we're going to be using alternate interior theorem. Here's our transversal cutting between the 2 lines. And they both are parallel lines because they've got the red arrows on them. And because they're parallel, cut by a transversal, we know angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, just because we happen to get those parallel lines. Our next theorem is the consecutive interior angle theorem. Now this one is a little bit different. You have to be careful. I've got two parallel lines cut by a transversal, and my consecutive interior angles are not congruent. And you can kind of tell by looking at them. One looks obtuse, number 2 looks like it's acute, but they are supplementary. So angle 1 plus angle 2 equals 180. And angle 4 plus angle 3 equals 180. That is our consecutive interior angle theorem, sometimes called same side interior. And the next theorem that we're looking at, you guessed it, alternate exterior angle theorem. So just looking at our alternate exterior angles, when we have two parallel lines cut by a transversal, I'll label it T. Looking at our alternate exterior angles, angle 6 and angle 8 will be congruent, and angle 5 and angle 7 will be congruent. If we have two parallel lines cut by a transversal, this will be true. So all three of these and the corresponding angles before that require that you have two parallel lines cut by a transversal. Okay, the perpendicular transversal theorem. Okay, this one is just kind of a common sense theorem, and it states that if in a plane we have a line that's perpendicular to one of two parallel lines, then it must be perpendicular to the other. Because the two lines are parallel, and we have one right angle here, by the corresponding angle postulate, we know we must have a 90-degree angle here. So this one is kind of redundant with the corresponding angle postulate. Okay, for two given angles, determine the relationship. So let's look at what we have here. Angle 7 and angle 2. Let's put on our parallel sign, because I have to know that these are parallel to get this information. So I'm going to go ahead and put the arrowheads on there. Let's see, 7 and 2. They alternate my transversal. I'm going to label it T here. They alternate the transversal and they're outside. Let's see, that would be alternate exterior angles. How about 2 and 3? Oh, 2 and 3 are right next to each other. They're not going to be congruent, but we know they sit on a line, so angle 2 and 3 are a linear pair. Therefore, they are supplementary. How about 1 and 5? Boy, they both are on the left side of the transversal, and they both sit above their parallel line, so they are in corresponding locations. So those are corresponding angles. Okay, I'm going to move this just a little bit so I can see it a little bit better. Switch colors. Find the measure of each angle if angle 1 is 125 degrees. Okay, so I'm moving to green here. Let's see, angle 2. Angle 2 is right next to it. So 1 and 2 are a linear pair. So let's see, 180, because I know that linear pairs add to 180, minus 125 equals 55 degrees. That's how I would get my answer. How about angle 4? Hey, let's look at it. 1 and 4 are linear pair because they sit on a line together. Has nothing to do with the parallels. So it also must be 55 because angle 1 and 4 must add to 180. Angle 6, let's see. Angle 6. If angle 4 is 55, angle 6 is 55 degrees. Okay, it's an alternate interior angle with angle 4. How about angle 8? Look at angle 1 to angle 8. They're both exterior and they're alternating the transversal. So they are alternate exterior with angle 1. So angle 8 is the same measure as angle 1, 125 degrees. Okay, let's see if we can fill out this chart. We have two pairs of parallel lines. Wow. Okay, let's look closely at this. It says A is parallel to B, C is parallel to D. And angle 1 is 63, so I'm going to start right there and put in my 63 degrees. So let's put it in here, 63 degrees. Okay, so that makes angle 3 180 minus 63, or 117. Check me on that, but I think it's 117. So that would make angle 2, which is vertical to angle 3, that must be 117. And angle 4, which is vertical to angle 1, must be 63. Okay, angle 4 to angle 7, those are corresponding angles. So angle 7 and angle 4 are the same measure. And let's see, angle 2 and angle 6 are corresponding. So angle 6 has to be 117. And let's see, angle 5 and angle 1 are corresponding. So angle 5 is 63 degrees. And angle 8. Angle 8 corresponds with angle 3, so they would be the same. So if angle 3 is 117, angle 8 is 117. Let's see, now I need to move on. Maybe move on over to this group here. And let's see, I said angle 2 is 117. So 117, angle 2 and angle 10 correspond. So angle 10 must be 117. And angle 1 and angle 9 correspond. So angle 9 is 63. And then from there, I've got verticals. 9 and 11 are verticals. And 10 and 12 are verticals. And let's move from 9 to 13, or we could go from 5 to 13. 9 to 13 are corresponding angles, so 13 is the same as 9. And let's see, 12 is the same as 16, so 16 is going to be 117. And angle 14 is corresponding with angle 10, so they're the same, 117. And angle 15 corresponds with 11, and it's vertical to 13, and it's alternate exterior with 5, so angle 15 must be 63. Look at that. All of these angles, 16 angles, come down to 2 different numbers. Just 2 numbers. Okay, let's try one more here. Let's see what we have. Okay, if A is parallel to B, we've got one transversal here and another transversal there. So we'll be using one transversal and then probably the other transversal. Let's go with purple. Let's see, angle 1. Now we've got this angle right here is 110. Angle 1 is vertical to it, so angle 1 must also be 110. Close the door, please. Angle 1 and angle 4 are linear pairs, so they must add up to 180. So angle 4 is 70 degrees. I'm going to write that in my diagram right there. Okay, so let's look at the parallel lines. Let's see, I've got 180 there. I've got 1, which is same side as angle 2, so that maybe doesn't work. But I've got going this way, let's see, we've got 1, this whole angle corresponds to the 110. So I know this whole angle is going to be the same as this angle, 110. And I know the 70 is the same as angle 2 because they correspond. So this is going to be a 70 right here. And that will give me a 70 will give me the same as 3 because those are corresponding. So this will be a 70. Okay, angle 3. Oh, that doesn't make sense. Angle 3, I know what. Angle 3 and 50, those are a linear pair. So instead of saying angle 3 is 70, that's not right. 180 minus 50 is 130. Okay, so that means that this angle over here must add up to 130. Okay, and this angle, remember, is 110. So let's see, if this is 70 and angle 2 is 70, but the whole thing is 130, that means this much right in here must be 60. So if this is 70 and this is 60, what's left over? I've got 130 here, so angle 5 is 180 minus 130, or 50 degrees.
To the attendance office. Also, Rachel Berkeley to the front office.
Okay, let's see if we can complete this proof. We've got different proofs, all using the same picture, so we're going to try using different proofs. A and B are cut by T. Here's our T, our transversal. 3 and 7 are alternate interior. 3 and 7, I can see that, are alternate interior. And how do I know that? By the alternate interior angle theorem. A and B are cut by transversal T. 6 and 7 are same side interiors, 6 and 7, and that would be the consecutive interior theorem. A and B are parallel. Angle 1 is congruent to angle 5. Let's see, angle 1 and angle 5. Well, those are alternate exterior angles. So that's the theorem that told us that. A and B are parallel. 2 is congruent to 6. Let's see, 2 and 6. Oh, those are alternate interior angles. And over here, A and B are parallel. 2 and 3 are supplementary. That would be same side interior angles, or consecutive interior angles. And the last one, A and B are cut by T. 8 and 5 are corresponding. 8 and 5 are corresponding. Let's see, that's corresponding angles and then linear pair. We can call that same side exterior angles.